Welcome back, my little geologists. Now, before we start talking about density and hefting, I want to first talk a little bit about, or go back and amend something that I said in our hardness video notes. So I want to make sure you add to your hardness that hardness is determined by a scratch test. I forgot to add that before. I meant to. It's in my notes, and I just forgot to do it. And I didn't want to record the entire video over again. So I just instead made sure I added it here. You want to make sure you remember that hardness is determined by scratching it, either on different minerals or with like a nail and penny and fingernail, that kind of thing. So make sure you add that. So then we move on to density. Now density, you guys have had tons and tons and tons of practice with density. So this should all be review. But we're still going to go over it because it's something that you need to remember. So, density. Each mineral has a characteristic density. Recall that density is the mass in a given space, or mass per unit volume. No matter how large or small the mineral sample is, the density of that mineral always remains the same. For example, the density of quartz is 2.6 grams per centimeters cubed. The density of diamond is 3.5 grams per centimeters cubed. To measure density, geologists use a balance to determine the precise mass of the mineral sample. Then they place the mineral in water to determine how much water the sample displaces. The volume of the displaced water equals the volume of the mineral sample. The mineral's density can then be calculated using the formula below. Density equals mass divided by volume. So back to our notes. Again, like I said in the hardness video, I'm not going to put a date for this one because I don't want to break up my mineral identification. The next is density. And underneath density, I'm just going to put density is found by dividing the mass and volume. Just so I remember when I look back on my notes that density is found mass divided by volume equals density. That makes sense, right? So now you're probably wondering how on earth, or what on earth is hefting? Hefting is something, it's not a bolded word in your book, and it's not necessarily one of the ways that geologists determine the identity of a mineral. It's too ambiguous. It's not a very scientific way to find it. It's kind of more of a guess. But hefting is important, especially for geologists that are out in the field. So let's read about it for a second. You can compare the density of two mineral samples of about the same size. Just pick them up and heft them, or feel their weight in your hands. The sample that feels heftier is probably also denser. So in my notes, I'm going to make sure I add hefting. And hefting is when you put two mineral samples in your hands. I'm going to back up a little bit so you can see. Two minerals in your hands, and you determine which one feels heavier. Whichever one feels heavier is probably also denser. So, hefting. What should we put for hefting? Let's put that hefting is when you put a mineral sample in each hand and determine which is heavier. The heavier sample is the more dense sample. So let's explain that for just a second. When you heft something, you determine which one feels heavier. And remember, when we were doing density before, that the more dense an object is the more mass that it has. So as the mass went up, the density went up. And that's the way we use hefting to determine which sample we think is more dense, which one has more density. Out in the field, geologists don't always have a balance beam with them to find the mass and a graduated cylinder with water in it to find the volume. Instead, they need to determine right on the spot which one is more dense, which one has a higher density. They use this method of hefting to do that. So now that we've talked about hefting and density, you guys are going to get the chance to practice yet again. So on your to-do list, you're going to find the density and hefting lab. You're going to complete that, and then you'll see me again for some more video notes. I'll see you on the flip side.